All right. Question one on percentages says Kevin took a math test and got 45 correct and 5 incorrect answers. What was the percentage of correct answers? So that'll be 45 out of 50 times 100. 45 out of 50 times 100. So the first answer there is 45 over 50, 100. And you got the answer right the way I'm looking at it because that's 90%. You say 50 here 1 and 50 here 2. 45 times 2 is 90%. So you got that right. Then a metal bar weighs these ounces. 91% of the bar is silver. So how many ounces of silver are in the bar? Okay. So this time around, what did you get for number two? What did you get for number two? You're muted.
I couldn't get the answer to that one.
Okay, so please concentrate, okay?
Oh,
Yeah. So it says a metal bar weighs these ounces, that is 14.15 ounces. So 90% of 14.15 ounces, of the bar is silver. So it now says how many ounces of silver are in the bar. Just find 90% of 14.15, okay?
good.
Exactly. I mean
Yes.
91%, not 90%. So
Yeah.
91%. Hold on, please. Excuse me. So 91% of, that's times 14.15 ounces. That's 91 over 100 times 14.15. Or I can change 14.15 to 1415 divided by 100. It's for easier manipulation. So I'm just going to multiply 1415 by 91, okay?
Good, good.
Then I'll divide by 10,000. So what is 1415 times 91? Let's quickly do that. 1415 times 91, that is 1415 times 91. So 1 times all the numbers gives me all the numbers. And 9 times 5 is what? 45. Then 9 times 1 is 9. 9 plus 4 is 13. You keep 1 again. 9 times 4 is 36. 36 plus 1 is 37. You keep 3. And 9 times 1 is 9. 9 plus 3 is 12. So we have 5, 6, 7, 8, 2, 1. So we have 128, 765, okay?
Okay.
Then if you divide by 10,000, just count for 1, 2, 3, 4. So this is going to be 12.8765 ounces. So if you are just going to take two decimals, since we have two decimals there, the answer is going to be 12.9, okay? Or 12.88 rather. I took it. So 12.88 ounces. Is that clear?
Yes.
Okay, so 12.88. 88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. 12.88. says. So the next one says a baseball pitcher. Let's see. Let's take this to the next page and quickly address it. A baseball pitcher won 60% of the games he pitched. If he pitched 40 ball games, how many games did he win? So just find 60% of 40, okay?
Okay.
60 over 100 times
Yes.
40. So we got two zeros at the top and two zeros at the bottom, canceling themselves. So we have 6 times 4, and that is 24 games, okay?
Okay.
You got that?
Yeah.
Okay, you got 24 games. And see, the last one there, number 4, says there are 60 students in a class. 50 of those students are men. What percentage are women? So that will be 10 out of 60. So that's 10 over 60 uh, times 100. Okay,
Uh,
is that clear?
yes.
So we got 1 0, cancel 1 0. Then we have 100 over 6%, and that's going to be, if you reduce by 2, that's 53 divided by 2 over, 50 over 3. Then if you divide this all the way down, how many 3 goes here? That's 1. Remainder 2, 3 goes in 20? That's 16. Then 2, let me see, 16, 2 over 3%. But I'm trying to check this percentage stuff since we're dealing with people. There are 60 students, okay? 50 are men, and what percentage of the class are women? There are 10 women, so 10 out of 60, then times 100. Okay, that's it. 16.66%, that's correct. So you go 1, 2, 3 out of 4. So I'll quickly put down your correction, then we'll move on, okay?
Okay.
Yeah. So viewers, thank you very much for watching this. You can subscribe to this channel for updates on our future videos. Bye for now. See you. So to continue with this listing of the elements, we have the next one to be after boron. We have carbon. Carbon represented as C, and the let's see, the atomic number is 6 rather. So which means it has 6 electrons and 6 protons, and the neutrons in carbon we have 6 neutrons as well. Okay,
Okay.
then there is a significant meaning to number of neutron and number of protons. Take note. Let us indicate that neutrons plus protons equal atomic mass. Okay, is that clear?
Yes.
Hence, we can say what is the mass of carbon? the atomic mass of carbon equal 12. Where did I get 12 from?
6 plus 6.
Is that clear now?
Yes.
So what if I ask you for the atomic mass of hydrogen?
Um, 0 plus 1. That's 1.
That's 1. What of that of
4,
4? What about this one?
7,
What about this one?
9,
And what about this one?
11.
Though there might be discrepancies when it comes to atomic number, but basically it is the number of protons plus neutron that gives us the atomic number. Is that clear?
Yes.
Okay. I mean the atomic mass rather, not the atomic number. Because we already have the atomic number and that is the arrangement. That is what is used for the arrangement. So we can continue from number 7, which is nitrogen. So here now we can say nitrogen, let me write it, nitrogen represented as N as the atomic number 7, that is atomic number 7. Then the number of electrons in nitrogen is 7. The number of proton is 7. The number of neutron also is 7. Then the atomic mass is 14. Okay.
Okay.
So the next one is oxygen. The oxygen we breathe in. So that is represented as O, and that is 8, 8, 8, 8, and the atomic mass is 16. Then the next one is fluorine, okay,
Okay.
represented by F, and this is 9, 9, 9. In fluorine, there are 10 neutrons. So this will make this to be 19, okay?
Okay.
Then the next one is neon, neon Ne. So there are 10, 10, 10. And in neon, the number of neutrons also is 10. So which will make the atomic mass 20. Then in sodium, represented with Na, take note of that. So we have 11, 11, 11, but in sodium there are 12 neutrons, and this will make the atomic number 23. Okay.
Okay.
Then in the next one after sodium is magnesium.
Wait, sorry. The first N that is above 7. What does that mean?
It
What's the meaning of
means
that?
atomic number. Okay.
What about the E and the P and the N?
Electrons, protons.
Okay.
Okay, this should be small letter here. Neutrons, okay? And this is atomic
Okay.
mass. That first one is atomic number. This one is atomic mass, okay?
Okay.
That is the mass of one atom of that element. So if there are two atoms, the mass will be multiplied by 2, okay?
Okay.
If there are 100 atoms, you multiply that mass by 100. So, magnesium represented with Mg, capital M, small g. Then we have 12, 12, 12, and the neutrons is also 12, which is 24. Then But you will take note of the mass. We did not put grams because the unit of mass should be grams or kilograms. We don't put grams because this is just a measurement in terms of the weight or the mass of hydrogen. So it means nitrogen is 14 times heavier than hydrogen, and magnesium is 24 times heavier than hydrogen. Okay,
Okay.
it's a mass, but we don't use grams for that. Now, magnesium. Okay, after magnesium, we have aluminium. Aluminium. So Al. So for aluminium, represented with Al, it's number 13. Okay, is that clear? Instead of
Yes.
that, so number 13. So it has 13 electrons, 13 protons. And in aluminium, the number of neutrons is 14. That accounts for 27. And like I said, okay, I think I've explained that one before. So what I wanted to mention is that this means that aluminium is 27 times of hydrogen's mass, and nitrogen is 14 times of hydrogen mass. That's what it means, and that's why we don't use gram for this measurement of their mass. Then, after aluminium is silicon. Silicon, Si. So this is going to be 14, 14, 14. And in silicon, there are 14 neutrons also. This is going to be 28. Then the next one is phosphorus. Phosphorus. So in phosphorus, phosphorus represented as P, and means there are 16, 15, not 16, this is 14. So 15, atomic number is 15, the number of electron is 15, number of proton is 15, but the number of neutron is 16. That will be 31 for the atomic mass. Then in the next one is sulfur. Sulfur. For sulfur, we have S as a symbol, then 16, atomic number is 16, number of electrons 16, number of protons 16, and number of neutrons also 16, and that is 32. So it means that one atom of sulfur weighs 32. So three atoms is going to weigh 96. Is that clear?
Yes.
Then the next one is chlorine. Chlorine. Yeah. Chlorine is represented with Cl, and the atomic number is 17. This is 17, this is 17, but this is 18. That is 35. But we have another form of chlorine that will give us 35.5 or something. But averagely it's 35 or 37, But those are isotopes. We'll talk about that later. Then chlorine, after chlorine is argon. Argon, we're referring to first 20 elements. So for argon, in argon, we have the symbol is Ar, atomic number 18, electrons 18, protons 18, but the neutrons are 22. Okay,
Okay.
check something. Hold on a bit. A few seconds. So it has 22. That means the atomic mass is going to be what? What would be the atomic mass of argon?
Um,
Remember, remember you had the
40.
protons and neutrons together. So,
Hmm.
what's the
But
atomic mass of argon?
but
40, right?
yes.
Though it's accurately it will be 39.9 something or 39 point, but it's 40 at least to use, say, this. So, that's argon. After argon, we have potassium. Potassium is represented with K. Take note of that. Then that is 19, atomic number 19, electrons 19, protons 19. The neutrons are 20, and this gives 39. So if I give you the atomic mass and I give you the number of neutrons, then you can find the number of protons. And once you know the number of protons, you know the number of electrons, then you know the atomic number. Is that clear? Okay.
Yes.
So the last one in the first 20 element, we have calcium. Calcium is number 20. Okay, so the symbol is Ca. The atomic number is 20, electrons 20, protons 20, and neutrons also 20, and that's also 40. So you can see it as same mass or roughly the same mass with an argon. And that is where we'll be rounding up your science for today. So just put down all of these details. Your job as homework will be to study all of them. Be able to tell me all the first 20 elements from accordingly from the first to number 20, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay?
Okay.
Then be ready to mention their symbols, their chemical symbols. Like hydrogen is H, helium is He, lithium is Li, okay? And so on until you get to calcium Ca. Is that clear?
Yes.
Okay, round up with what's on the board. Okay, viewers.
Already said.
All
Yeah.
right, just hold on, okay. All right, viewers, thank you very much for watching this. Uh, Please subscribe to the channel for more updates. Goodbye for now.